part 5, I think. Anyways, all right, the next step is you're going to vacuum filter that solution. And this is what a vacuum filter looks like. You're going to want to use, I need to clean that. You're going to want to use one of these. Otherwise, it will take you a long time to filter out the solution. See, I even have a vacuum pump hooked to it. It's a hand-powered one. It takes about 15 minutes. You got to keep taking the solution out of the bottom of the bottle and filtering it back through until this comes out clear. Now, I have, from my own personal experience, discovered that you can filter out enough of the particles to actually reuse the solution. See? Clear. Now, yes, you can reuse it. Yes, it will work. But every time you reuse it, you're getting less and less good product out of it. Next step, after you've filtered it out and gotten your graphene out, I went as far as baking it. I took a glass thing. Oh, where'd it go? Huh. Yeah, this right here. I took this for making bread, threw my graphene in here, and baked it in my toaster oven. Cooked out whatever residue was left in there, your acetone, your water, got rid of all that extra stuff. Now the heptane and the rubber cement. Robert Murray Smith has told everybody who's been working on this, and I may have mentioned it in the videos, but if you talk to him, the first thing he's going to say, if you're going to apply a binder, you want 10% of that binder to your graphite solution, graphene, whatever you want to call it. It is a mixture of graphene and graphite, so graphene-like material to your binder. Now, my binder, I chose to use rubber cement because rubber cement is flexible. I originally was trying to make a natural rubber and make that work. I couldn't get it to work fast enough for my liking. I'm kind of impatient. I'll probably go back and revisit it because it is a fun chemical experiment to use. The last one I did come out something similar to this. It's kind of nasty. I'm not even sure what it's doing now. I'm just letting it sit and I'm checking it out as it goes. But so you take the rubber cement, you'll have to play with the amount of heptane you put in it. More heptane, the less binder there is involved. Basically what rubber cement is made from is rubber and heptane. So the only thing you're doing is thinning out the amount of rubber that is in the solution. So you're not actually destroying any of the binder. Now there are other solvents you can use. I don't know what they are, but that's the best one for that particular item. Now once you've done that, you can mix in as much graphene as you want to it, or graphene-like material as you want to put into it. There will be a maximum amount you're going to want to put in it, and there'll be a minimum. I don't know what those are because I haven't figured it out yet. The less you put in it, obviously the less conductive it's going to be. I tried using just the pure graphene in it, and for some strange reason I can't get it to conduct. The graphene is the only thing that actually sits in solution permanently. I haven't got it to separate out of solution at all. In fact, I got some of it right here. As you can see, it's almost opaque, but I could paint that onto a surface, but I get absolutely no conductivity out of it. Now, what I've done is I poured that off the top of my solution I made here, and as you can see, that black solution on top is the same stuff that I was just showing you in that other bottle. I just poured off a lot of that, and all this down here is actual, I don't know if you can see it, it's graphite like. It's graphene, graphite mixed together, but most of it's graphite. I mean, it's what it comes down to. Now you can skip the acetone step entirely and just use the heptane rubber cement. You just have to be careful not to let the temperatures get too high. Heptane is actually flammable. You get it above a certain temperature and it will ignite. So you want to keep this relatively cool in your ultrasonic when you're sonicating it. And that is one way of making a rubber ink. I've gotten my particular ink down to about 200 ohms unless I anneal it, and when I anneal it I can get it down to about 20 ohms per square. Alright, that's part 5.